Hey everybody, I'm going to start here in about 30 seconds to a minute. Wait for a few other people to get in here. If anyone has any questions throughout the presentation, just feel free to type them in the chat box, and we're going to do a live Q&A kind of at the end of the presentation, whether it be questions for myself or we have a special guest, Jay Irwin, on, who is the chief operator at the village of Sherman, New York, up there outside of Buffalo. So type in those, and then we'll try to get to as many as we can within the end of the presentation. If not, we will definitely get them answered after the presentation as well. All right, everybody, I am Brad Hitselberger. I am the business development manager for our municipal product offerings here at IFS. We're super excited to talk to you today about this direct inline pumping system, which is branded as the OverWatch. We have a special guest, so it's a really good opportunity for everyone out here to ask questions for somebody who's had this pumping system for 5 or 6 years in the US. So you get a rare opportunity to talk to a chief operator and get his experience, and here's experiences firsthand with it. So I'll go ahead and kick this off and get started. All right, so the agenda, I'm going to go through about IFS, about the OverWatch Direct Inline Pumping System, do a quick product introduction, and then do a product demonstration. We're actually here at the factory today, and we have a live demo loop. So we're going to be flushing with some lacrosse balls down it. You can kind of see the control panel, how it works, how it regulates, how it goes on, off in linear mode, and different, all the good stuff like that. And then we have a case study we'll present with Jay Irwin, and he'll share his experiences with the system, and you guys can ask some questions to him, and then you can ask questions and answers about the product. So I'll go ahead and get kicked off here. I'll go ahead and introduce Jay Irwin. He is the chief operator at the wastewater treatment facility in Sherman, New York. It actually got installed 5 years ago, before Industrial Flow Solutions actually bought this technology from over in Europe. So he's one of the first people to have it in North America, one of the longest installations, longest experiences with it. You'll get a full glimpse if you check out our YouTube channel of a great YouTube video that is actually at his facility. You can go out there to the YouTube and see exactly how it performs and his thoughts and exactly where it is at his wastewater treatment plant. So it's a really good opportunity to do that. About IFS, we are actually located in New Haven, Connecticut. So everything is American built, everything's fabricated here. We do have facilities over there in Europe and United Kingdom and Italy too, factories over there. Everything's designed, manufactured. It's a great big facility where we actually have R&D here, engineering, upper management, customer service. There's a lot of inventory on the shelves, which is awesome. So it's great that we're in North America for short lead times. And everything, all the testing facility, you might see it here behind me once we show the product demonstration, but you can see everything's tested to HI standards. So you'll get a good overview of that. How this IFS formed, they formed in 2017. You may be familiar with some of the other products and brands that we offer. BJM and Stancor are two of the legacy brands, and that was back in the 80s. Those came together when Industrial Flow Solutions formed. And 2019 is when Industrial Flow Solutions bought the rights to OverWatch, brought it over to the Americas, and since then there's been a couple other acquisitions with Clearwater Controls, which is the deragger module that some of you might be familiar with in municipal applications, and then Drano, which is a pump manufactured over there in Italy that's submersible pumps for municipal applications. But here's a good overview too of what I was just talking about, the different brands that manufacture, all up represented by Industrial Flow Solutions. And they touch on all different industries. And the good thing about the pump we're talking about today, it touches on everything from commercial, industrial, municipal. So it's a problem solver for all different types of applications. This makes this really good. The other brands we serve in different applications as well, whether it be food and bev or different pharmaceutical applications or industrial applications, mining applications. But the pump we're going to talk about today is the pump called the OverWatch, which is a direct inline pumping system. So what it essentially does is it eliminates the wet well. When you think about wet wells, you need a wet well in a normal traditional lift station. Whether you have a dry pit pump and it's in a clean, dry environment, you still have a wet well that you have to deal with. And when you have submersible pumps, you have those pumps submerged down in wastewater. So if you eliminate the wet well, there's a lot of value propositions for this. You know, you're actually increasing safety risk, you're increasing environmental improvements with this, exposure to dangerous gases. When you think about the sewage and wastewater that gets polluted into the environment, it actually releases what we call H2S gas, which is hydrogen sulfide gas. By releasing that into the atmosphere, that can actually cause airborne illnesses to different associates and operators who are working on it. So by being exposed to it, you know, you're potentially, it could actually become fatal. So wet well maintenance forever is one of the main big things too. Unscheduled maintenance is a thing I will highlight with this, and I'm sure Jay, once we get into it, will definitely share his experiences with the reduced unscheduled maintenance that he's had experience with. So when we say that unscheduled maintenance, you think about a wet well, there's back trucks you have to clean out, there's float maintenance for fouling, being hung up, coating issues. And then the back trucks, if utility is not fortunate enough to own their own, they have to rent these that cost $400 or $500 an hour. So all that gets eliminated with this technology. Here's a great bird's eye view of a packaged lift station with the OverWatch in it. And it just shows how easy it is to operate it, how safe it is for your operators who are going down there and have to do maintenance on it. Here is a picture of the OverWatch. I think this is actually in the bottom of a parking garage here, but this is the solution to not having and eliminating all those bats, oils, and greases. You're basically simplifying your maintenance, and how you're doing this, we're lifting directly from the point of entry. So all that influent, where that pipe's coming in, is going to be lifted right there at the point of entry. There's actually a level transducer, so you don't even have floats anymore. So you have simplified maintenance. It's sold, this is sold as a complete package, a turnkey solution with the control panel and the pumps. So how does it actually work with the control panel? It's going to do constant flow matching. You know, our package comes with VFDs, a pressure transducer. It's always communicating and monitoring that incoming flow, and it's matching it up to a motor speed to that flow rate. So we manage the flow as it comes into the system, and that's really the key. And if there's a clog, it has the capability to identify that before it becomes a problem. In most traditional lift stations, you can see that is not the case. These rags, wipes, fibrous material, it actually becomes a problem to the pump and can damage your pump. So we get in front of that problem before it happens. So key benefits of the OverWatch: no downtime from clogged pumps. That's kind of like what I mentioned here. We have a special dip cut patented impeller, which is a really cool impeller. It is a vortex impeller, and it's also a shredder impeller in one. And I'll show some pictures here in the next slide. But essentially, what that means is it's going to take any of those rag balls, anything that people flush down the toilet in the collection system, beach towels, all that type of stuff. We have a lot of good videos of us flushing a lot of different stuff down it, and it just eats it all up. So no regular cleaning. This is going to be all 304L stainless steel at the minimum. So if you have different industrial or commercial applications where you need 316L stainless steel, we can do that. But that allows for no erosion and corrosion. Everything in contact with that fluid is stainless steel. And optional remote monitoring. Again, we have a UL 508A panel shop here at our factory, and that means anyone else can do with control panels. We can do it here. If it's possible, we can do it. So any different type of Modbus or BACnet protocols for your certain SCADA system, or if you need some radio waves to get called out on your cellular device, you can do that. So you're getting monitoring in real time of this system. Create safer working conditions. This is a really big benefit. You know, since we don't have that hydrogen sulfide gas, it's gonna create a safer working environment for your associates. And the amount of downtime too with this thing, the reduced unscheduled maintenance is very minimal. The unscheduled maintenance, so you don't even have to go down there as much as you would a traditional dry pit station or a submersible station. So everything is contained. You know, no effluent is being exposed to the atmosphere. There's no holding tank like you see in some other applications. There's none of that. reduce environmental impact as well. Your equipment around this stuff is going to last long. If you go out to different wastewater treatment plants, or you go to other applications and you see the H2S gas that becomes very septic, it actually can corrode away at your control panel. It can corrode away at the basin. And you can see the rebars sticking out. So by not having any of that dangerous gas exposed, your equipment's going to last longer. It's going to have a better environmental impact overall. Odor pollution. So because the fluid isn't hitting that open atmosphere, it's not something we have to worry about with this system. So you can save big money on odor compression systems. You don't have to buy additives anymore for stuff for lift stations that are right outside of neighborhoods. And then we minimize excavation with smaller footprints. So the great thing about this system is the whole body of it can be completely customizable, which I will get into and show you standard configurations of our body, but then we can get very creative with it and make it fit a certain footprint, and that helps the environment out when we don't have to dig these huge holes to make in the ground to make a traditional lift station work. You can just install a direct inline pumping system and save a lot of money and help out the environment with it. So here's the best slide if you want to get a full picture of what the system is. So this is not including our control panel that we provide with this. What you'll see is, I'll call it out from going from right to left and back up. You'll see the sewage coming in that pipe right there. What's called out is the stainless steel wall flange, which is basically an optional adder you would have basically for your application. If your gravity invert is not poking out, say if it's recessed or if it's flushed, that's when you would need that just for mounting purposes. Main isolation valve would be called out right there beside it. If you need to isolate each motor and each pump, you can do that right there. Stainless steel level transducer. So that is what's doing all the communicating. That's actually what is, that's what's eliminating the floats in a normal traditional wet well. So the way that thing runs, it's communicating back up the control panel, and it will run in two different modes essentially. It's going to hit a high level, turn your pump on, and pump it down to a low level. Now, that's going to be the linear mode, and you may see that mode probably, I would say, my best example is 4 o'clock in the morning, you know, when no one's really using water or sewage or wastewater, and it's kind of sitting there idle. Now, when you'll probably see it run in the other mode is this PID algorithm mode. And that PID algorithm mode is when the VFDs are kicking on. So the VFDs are going to kick on, and it's going to be a set point that you set based on your application in between that high level and low level. So it's going to want to regulate. It's going to want to regulate at some point in between that. I think today, the set points I set up on the demo unit behind us is going to turn on at 1 foot 3 inches of water pressure, try to pump it down to 2 inches of water pressure. Now, then it's just going to try to regulate at about 8 inches of water pressure. So you'll see it fluctuate, the hertz on it go up and down based on the amount of flow that's coming in to try to get that water through the system. So that's really key for how this thing works. It keeps solution moving through, doesn't give it a chance to stagnate. And by doing that, that's how you eliminate the fats, oils, and greases that you typically see that cause all the issues in traditional wet wells and traditional applications. Going called out right below that is the stone trap cleanout. This thing is a safety mechanism basically for the pump. So in collection systems today, in wastewater today, you hear about people flushing 2x4s down the collection system. I've heard bowling ball pins. I've heard some crazy stuff out in the field. But what that's going to do, it's going to sit there in that stone trap cleanout. So it's not going to go up into those branch ways that you'll see on the left of that stone trap cleanout. It's going to sit there, and then regular periodic maintenance, you go in there and check it, and you can clean out whatever's in there. The branch ways going up to that branch isolation valve, those things range in about 3 inches to 8 inches. The smaller ones are 3 inches. The one today we'll show is the 3 inches, and then the bigger one, the 200 horsepower pumps, are 8 inches. So if it can fit through that, it's going to go out to your pump and go back out to the force main or back ever where the discharge is going. There's going to be a branch isolation valve called out next. That branch isolation valve will be on each side. You can get a better picture of that beside me or behind me after this. And then we have the impeller, which is the dip cut impeller, which I'll get into. That's that very special impeller that's going to be looking at your torque values, your flow values, and your pressure values. And when it's looking at your torque values and it gets out of that standard deviation, that's when it's going to expose the knives and go into reverse. The motors are called out here. These things are IP67 premium efficiency motors. So that IP67 basically just means it is immersible. And it's 1 meter of water pressure for every 30 minutes. So that is what IP67 means. So if something does happen, an accident does happen, I gets in there, somebody leaves a hatch open, rainfall gets in there, and they do get submerged, they will operate up to a certain up to that certain rating, IP67 at a minimum. And they can't operate longer than that. That's just what the IP67 rating is. Going up past that, you'll see it's kind of a common discharge. And the good thing, like I said, is this thing is completely configurable for your footprint. So you can split those discharges, have separate discharges, have a good lockout, tag out procedures, do the proper safety procedures if you want to isolate properly each of these valves, which is a lot of municipal applications. Swing check would be provided, and then there's an optional flow meter, and then missing from this, there'd be another isolation valve on top of that. But you can see this is going to be designed typical application, full redundancy, 100% capacity. You want to size it for your peak load. So if something happens with one pump, the other pump will kick on. Just like your traditional duplex, we give you that redundancy there. And we'll go over a normal operating condition real quick, show you how this is how it's going to be operating majority of the time in your system. Flow will come in, sewage will come in, wastewater will come in. Everything is contained. You'll have whatever impeller it is here. Here's that dip cut impeller that's displayed there. It's going to be a vortex impeller in normal operation. So your lead pump will be acting as it will be a vortex impeller. It will be moving, passing 3-inch solids. You'll see today when we flush down these lacrosse balls, it's going to pass this thing whole. So we'll pass a 3-inch solids very easily, just like any other applications. And then it will go right back out to your discharge, and then right back out to the force feed or wherever it's going from there. So here's another scenario. Real-time pump protection is what this system has. So this is when we detect that we have a clog. So if there is a clog, we're monitoring that profile. And when it deviates from what it should be, that's when we react. We know exactly where that torque profile should be from that 0 to 60 hertz range. So if it's running at 38 hertz, we know exactly what amperage it should be drawing. If it deviates from that and it hits 110% of your full load current percent, that's when it's going to stop and go into reverse. So you can see it's acting as vortex in this picture. It's seeing that flow is detected, or it's seeing that the torque is detected and it's deviating from it. And the good thing about it is none of your capacity is going to be lost. So sewage is still going to be pumped, but it's going to be pumped with the other pump. So that's why we have that full redundancy system. So the other pump that is getting the clog is actually going to flip down, expose those knives. So I think this PowerPoint is very powerful right here. You can see it going from vortex down to a shredder. When it's doing that, the shredding cycle, everything is customizable with this thing, but the shredding cycle, the impeller shreds for about 30 seconds. Then it will check its torque profile to know that the line is clear, and see if the line is clear, then it will go back into that lead operation if you want it to. If not, and it's still deviating, it still hasn't shredded up everything, it needs more time to shred it up, that's when it will go back into that 30-second mode, and then it will do this about 20 times before basically it will give you a fault call out that, hey, I can't shred whatever's in. So another operating condition. This is peak elevated flow. So say you have a 100-year rain event. You didn't size, somehow this pump did not get sized to the right capacity, or you had extra houses now feeding into this line that you never predicted in the future. You can actually run these together in parallel. So by running these together in parallel, you can get 150, 160%, whatever that calculation is to it. So what the system is looking at, how it works, the logic behind it, the online pump will be running. It's running at 60 hertz, full speed. And when it's running at 60 hertz, it's going to be backing up in the system. The pressure's backing up. It knows it can't keep up. And that's when the other pump will kick on. So then both pumps will come. And when you do that, you increase your capacity. So different impeller options. The one we like to highlight, I will show you guys it here in a little bit. And it is the dip cut impeller that we have. And this is acts as a vortex, goes back into shredding when it detects that torque deviation. It has rags or rag balls or wipes or anything like that. So this is very unique impeller that a lot of people like when they have a lot of problematic lift stations. They install this, and you can hear Jay's experience with his application on here at the very end. But there's also different impeller options too. If you have something, want more of a high efficiency impeller option, you know, we do have that. That would be our T4 impeller. It's more for like stormwater applications or things that aren't typically going to clog. But everything is made out of stainless steel, so it's very robust material. It's made to last. So maintenance on this thing, and I think it's going to be very powerful when Jay gets on here and experience his experience. You can hear how easy the maintenance is and how little maintenance he's done on it. So this is the motor mounting plate. It shows the wet end configuration. You have that motor mounting plate. There's a little seal leakage detection. So you can actually visually see if there is a seal leakage, or you could hook the dry contact up and get some type of call out if there is some type of seal leakage. The seals on here are tungsten carbide. So they are strong seals. So you can, strong seals basically mounted right up to this impeller mounting hub. And then there is that impeller with 4 little bolts. So you can spin this thing in reverse. It's not screwed in impeller, but it's super easy. And I know I've had to take the motor out and actually get to one of these impellers at a trade show, and it took me 5 minutes. So I know if I can do it in 5 minutes, people can do it a lot faster. This is the construction of the motor. This is the cast iron body on the motor, and they're basically just TEFC motors. So they're totally enclosed fan cooled. So that just means we're using that ambient air around it to keep it cool. When you have submerged motors, they're using that water. So we're using that fan cooled motor, that ambient air to keep it cool so it can do more starts and stops. These motors are all operated with these VFDs. The VFD is essentially a soft starter built into it. And then they're IP67 rated, meaning they can be submerged under a certain amount of time. If you need some type of explosion proof, that IP rating would just drop down to IP56. If you have things going on in Canada, you need the Canada regulations. We do have the CSA option for that as well. And then the great thing about this as well is really that this thing is completely customizable to what you want it to. So it's going to have all your basic functionality. It's going to have a VFD per pump. So if you have a duplex, you'll have 2. If you have a triplex, 3. You can do up to a quadplex with 4 VFDs. It's agnostic, so you can use certain VFDs if you would like with this, but it has all your regular capabilities. It's a HOA switch on the front. You know, it will detect clogs, spin it in reverse, and then get that clog free. We have different type of NEMA enclosures. We typically do the NEMA 3R enclosure, which is good for indoor and outdoor. If you want a dust tight enclosure, we could do a 4X. It's not an issue. And then we have the HMI screen on top of it. The HMI screen is that human mounted interface. So you'll see it just looks like an iPad. It's so easy to operate. If you know how to work an iPhone or iPad, it's very similar. And then you can do the touchpad or the keypads if you want as well, but the HMI is typically what we do. But it's all configurable to whatever you have. We would provide the IP address so that it can communicate with your network, whether it's SCADA or some type of BACnet or Modbus protocol. So it's all there, and the functionality and customizable control panel and stuff is there for you. So this is a great slide too. This is something I really like to highlight when you're thinking about high water table issues, bedrock issues where you can't drill down into the ground as far, and then you're thinking about new applications. You want to save on that total cost of ownership. Total cost of ownership has to do with the whole project. So you would have to think about the excavation depth, which is very costly when building a brand new pump station. You're reducing your combined space entry with these things as well. But look at this picture, you can see the Delta H on this. On the right is a traditional wet well system. This is the direct inline overwatch system on the left. We don't need to dig down as deep with this system. So we only need 23 inches from the center line of that gravity invert. So you're saving a lot when you're thinking about the big picture of this thing for your end user. You can see in that picture on the left, there's also a sump pump too that's tied back into the low pressure side in case anything ever happens, a hatch gets open or anything. But then you're saving on other things as well, like odor compression systems that are super costly depending on the size of your basin, and unscheduled maintenance. Having personnel going out there to clean sumps on a regular basis can be very costly. Having to go derag pumps is very costly and very time consuming. So when you're short on resources, short on time, the OverWatch is there to help you. So safety first. Yeah, this is a lot of good before or after pictures. I mean, you can kind of see the one in the bottom right. You can see that's in the Ritz-Carlton out there in Baltimore, and it's in a parking garage. So these things run super quiet. The different applications for this, we've had these 11 of them outside of the EPA building. They were actually producing sewage smells and odor out onto the streets of DC. They went with the OverWatch because they wanted to eliminate that smell, because it's never a good look having sewage come out of the EPA building in DC. But we've replaced traditional wet wells, pneumatic ejectors, above ground tanks, all sorts of different things. So you can kind of see the before and after pictures of this all. So there's other options too. If you want like a turnkey solution, we can do this. We can do it in concrete, fiberglass, stainless steel, and basically you plumb this up. It's all ready to go. It's a turnkey solution that you just plop right into the ground, and it's set up, hook up electricity, and it's ready to go. This is another good version of our OverWatch. This is a simplex unit. So there's one actually, I think, right outside of Sherman, New York, that someone has installed out there, but has all the same basic functionalities that the OverWatch duplex unit has. It's gonna do that flow regulating. It's gonna have that tip cut impeller to shred stuff. It's gonna eliminate that fats, oils, greases. A good example of this is out there at a concession stand. They were only firing up every Saturday. They were cooking hot dogs and hamburgers and everything. The grease, the fats, oils, greases was really stinky, but it was sitting there and becoming septic because they were only firing it up every Saturday. So they installed this thing. It was a smaller application, didn't see as much flow and didn't need as much head, and this has been working great. This is our booster of this thing, and we actually have one of these installed in that picture right there in the Washington, D.C. Dulles International Airport. So if you ever want to have pipes with inefficient slopes, you just want to accelerate, get some more velocity through your line. Maybe instead of building a whole new lift station you just want to get more pressure on your pressurized line, you can install this, and it could save you a lot of money in construction costs. And again, this is a system that has been around for a while. I mean, it might be new to your area, it might be new to your region, but it's actually been around since 2003, which is a really cool thing about this. This is started over in Europe and was brought here. I think Jay might have one of the first installations here in 2017, but there's 2,500 of them worldwide. And then they go up to 10,000 gallons per minute, up to 400 feet ahead. So they can get pretty high head on these things. The biggest ones are 200 horsepower and 56 different models. So it's got a big range of performance curves to match your needs. And in the US is where we have about 125 plus since our company took this over and has been bringing it to the US. So different commercial applications, industrial applications, municipal applications. We just had some go in Clayton Wastewater Treatment Plant outside, or actually in the city of Georgia, Atlanta, Georgia. We've had different industrial at pharmaceutical companies, different commercial applications outside of hospitals, even outside of prisons, where prisons have very problematic lift stations where they're flushing everything down there. So a lot of good applications. I mean, we have reference lists for all these where they're actually all installed. So if you ever want to go out and see one in real life, we could set you up with our distributor. You can talk to us, talk to the experts, and go out and see one of these things and see it actually in real operation. So I'll kind of dive in here with Jay and go over his specific application here. This is actually, they feed about, I think, 730 people and 140,000 gallons per day is the design there at a wastewater treatment plant. They were having to go out there, and I'll let Jay dive into this a little more, but they were having to go out there and clean out clogging, clean out these bar screens, and they wanted to improve their safety too. I mean, they had a super deep wet well, it was 20 feet deep. This actually got installed January 2018, and they are using the dip cut impeller out there. So it's been about coming up on that 5-year date with that installation out there. But all the problems it solved for Jay is that zero ragging clause, that confined space entry was actually reduced, and the hours of unscheduled maintenance. The number we've heard from Jay is 26 hours per year he was spending going out and doing maintenance on this thing, and now it's reduced to only 20 minutes in this 5-year span. So it's basically almost zero. And bar screens, that was having to be cleaned weekly. That was part of that maintenance. He was pulling buckets of rags out each time, and then that's all been completely eliminated. Back truck cleanings were being required once a quarter. That is saving them money. Doesn't even need a back truck to come out there. So this is when we're talking about that total cost of ownership, where you see this thing. This is Jay's numbers here that they were able to come up with, but having that problematic lift station out there and not having to send out all your personnel, use all that, that actually cost a lot of money, and eliminating that led to $8,480,000 or $480 of annual cost savings. So that's kind of, I'll introduce Jay. Jay, if you want to hop on, if you can unmute yourself and hop on, and if you want to talk maybe like 1 or 2 minutes just about your experience with it, and up there in Sherman, New York, maybe go over how often you've had to clean the stone trap, or have you found anything in there? Just different things like that.
Yeah, can you hear me?
Are you on, Jay?
Yeah, can you hear me?
Yeah, we can hear you, Jay.
Okay. He pretty much covered everything. The biggest thing for us, like I've said many times, is a confined space issue. So we've gone, like you said, from many hours to less than an hour over the entire time span we've had the system. We've been down there only, we had one issue, not even an issue, just a mechanical seal that had wear on it. So we were able to pull it out, the pump, replace the seal, and back in operation within a half an hour. And that's been the biggest thing safety wise that we've had. It's been a really simple system.
Yeah, no, that's awesome to hear. So I guess, what's the application for where your OverWatch is? It's inside the fence there at your wastewater treatment plant, is that right?
Yeah, it's on site. Our entire system is gravity fed with a 12-inch line to our plant and an 8-inch line from the plant itself. So we have 2 inlets. It was designed for our application, so we were able to put both inlets into the system. So everything's right here on site. It was fitted for an existing wet well. So it wasn't a new wet well, it was the one that we already had. So it was retrofitted to our application.
Awesome. Yeah. So how often is it running? Is it running 24 hours a day, or is it, what's the duty cycle of it?
Yeah, we have it runs about 30 gallons a minute for us here. It does run constantly. They switch every week, a 7-day cycle. So each, one pump will run for 7 days and it'll switch over to the other pump, all on its own.
And you have the dip cut in car, right? Has there been any ragging events? Like no ragging events at all?
We've had zero issues.
Did you have any concerns? I know, I guess, about any scouring or anything like that. Has that been ever a concern at your facility?
No. Before, yes. Now, no. The other pumps had lots of issues with the grit and stuff. These pumps show virtually nowhere with the grit and the stuff that we do get in the system.
What about what's your maintenance cycle for this thing? Because I know when we at the factory we say go try to check that stone trap clean out, once a month or so. What do you typically do at your facility with it?
we haven't checked it at all. We haven't had to check it at all, other than the seal. It's been zero maintenance, zero anything going down there. I don't know. It's that simple. It really is that simple.
Yeah. I guess, was there any questions online, Amanda, regarding for Jay possibly? You can go ahead and show the system if not, and then if anyone has some questions they want to ask Jay, the user experience from this thing, they can ask it throughout the chat. Go ahead and start putting my camera on here and show you guys this system here in a minute. All right, so let me turn my camera on here. Okay, and I will show you guys the system real quick, and then we'll get some of these questions answered at the end. And if there is more questions for Jay, we can get him to hop back on here and answer them. But here is, I'm blocking the video here of the pumps, but you can kind of see this is how it's set up in our facility here. We have a live loop. There's acrylic piping here, so you can actually see the crossballs we're going to shut down here. So this is what it would look like when it's seeing consistent flow. And everything is being done here, controlled by our control panel. I'll come over here and show you guys this dip cut impeller. And this is the impeller that I was talking about in the video. That's a special patented vortex impeller. So when it's going in its correct rotation, it's going to be acting as a vortex passing over the crossballs. And then once you are knows this fibrous material, it's going to go into reverse and expose those knives and start shredding. So that's why it is, there's not a lot of maintenance with this thing because of the way that thing is designed. So very cool impeller that got invented, but all good out here. We'll kind of shove some lacrosse balls down here. You can see how this thing passes some 3-inch solids. We got a couple of them down here. We got an orange one you can see going through. If I get my microphone going up here, you can kind of see it will be going through the volute. You can kind of hear it rumbling around in there. It's going to try to be passing this thing whole, and I'll shove this yellow one down and this green one down too. So you kind of see there it goes, the orange ball coming up here. You can see we have pump 2 running right here. You can see it's coming up here. It's gonna be passing this thing whole. I don't know which one's gonna go first. So all right, the green ball, and then we have one more coming here. Yeah, there it goes, the yellow one. So you can see this thing passes this hole. I will take you guys over to the control panel. If I can move this over here. And then I'll show you kind of what the control panel looks like. It's a really nifty, easy to use interface. So this would be what you see at the control panel. I don't know how good this is gonna look with the reflection, but you can see there's pump 1 and pump 2 on your home screen. It's gonna tell you what pump's on, what pump's running. You can see you have all your HOA switches in cases of emergencies. Pump 1 we have running today. We have the level set point at 8 inches. So that level set point is what we want this thing to regulate at. We have it ticking on and off ticking on at 1 foot 3 inches, ticking down to about 3 inches. And then once it sees consistent flow, which I got the valves cracked just right, that's when it's gonna regulate at 0.8. So you can see it's not even using 60 hertz. It's at about 32.7 hertz. If I go crack the valve, which I'll go crack the valve a little bit or close it, you can see it go down and up and fluctuate. That hertz will actually go up and down, and you'll see the level set points go up and down before it tries to get to that 8 inches is what it wants to regulate at. So I'm closing it a little bit. Let's see, it's at and now it's turning off because it hit that low level set point of 3 inches. So once it hits 1.3 inches, it will kick right back on. So I'll give it some more flow so it can hit that 1.3 inches, and you'll see this is how it's going to go in that linear mode. It's going to go on and off until it can get that consistent flow, and then it's going to regulate. And everything is really great thing about this thing is the trends and the data you can pull with this thing. You can actually look at different graphs on this thing and actually export it out to like your your Excel sheets and stuff. So if you want to look at how many times it did a clean a day, how many times it did a reverse, you can pull that and you can drill that down weekly, you can drill that down monthly, yearly, and you can go do comparisons and see, you know, how it's performing. You can go see how much current it's drawing. You can go see how many starts it started up in a day, what your daily current is, and then everything is all customizable too. So here's another good screen. It's a good overview of each pump. You can see the number of starts, the total energy used. You can see the number of trips, all of that stuff. So the interface with this thing is very easy to use. I'll sign in real quick with the admin. This is a admin protected. You can have different levels of security. If you have somebody that you don't want to touch the operating points of your pump, you can do that. And I will take you into some of the operating set points we have set up here today. So pump 1, you can see we want it to regulate at 8 inches. So I could change that to whatever I want. If I want to change it to 9 inches, 7 inches, whatever it is, we would go out and make sure this thing is commissioned right to it's the right level set point with the engineer and the end user. And then if you want to go to what you want it to turn on and on at, so the lead pump turns on at 1 foot 3 inches, and then it's going to pump it down to about 2 inches and turn off. And then you can change different number of starts, and which one will become lead, which one will become lag. You can do it time-based, the number of starts. You can do a lot of different customizable things with this. So it's a really easy to use interface. These things have Danfoss VFDs in there, but you can use pretty much any VFD you would like. And it's very, very simple, so easy to use, which is good. I will, I know there's probably some questions, Amanda, coming in. If you want to go ahead and maybe ask some questions. We'll try to get some questions knocked out here and let you guys maybe come up here and see the pump once these questions get addressed.
Okay, so there are a lot of questions. What is the maximum flow that the system can handle?
So the maximum flow, each side, like our biggest ones, the 200 horsepower, our performance curves, 5,000 gallons per minute on each side. So they can actually, they can handle more than that. Like if you run them in parallel, you can do that. You can have a triplex and run two in parallel and have one on standby. You could run all 3. So it really depends on the application. It can get pretty high up into flow, but 5,000 would be the biggest ones per side. So you have a triplex, and they're all running at 100%. Like it would be about 10,000 gallons per minute.
Does flow monitoring, flow matching reduce cavitation and impeller wear?
Say that again, sorry.
Does flow monitoring and flow matching reduce cavitation and impeller wear?
So the impeller wear with this thing, the great thing about how this thing is designed is you actually see that it has this conical shape on this impeller, and this is how most of our impellers are. So the fact that it's a recessed impeller, it's a vortex impeller, grit and sand, and you can kind of see how big this volute is. This volute is very big. It's sitting right up in there. It's going to be pushing all that grit, sand, dirt away from the knives, the blades, so they don't actually dull out, which is a great thing about this. And I would say that as far as cavitation and everything for this thing, I mean, it's going to wait and continue to have liquid build up in the system. It will go into a lower cavitation mode, basically. So wait for pressure to build up into the system until it corrects itself. And then it will shut off if it is experiencing too much cavitation. Since we're actually looking at the high torque and the low torque on this thing is what we're trimming above the liquid level transducer. So it's going to be able to do that auto correction cavitation mode, the program, and end up auto correcting itself if it sees cavitation.
Is it possible to install air or electric actuated main isolation valves opposed to manual operated?
Sorry, can you repeat that?
Is it possible to install air
Yeah, I don't think we have an application out there. That's something I don't think would be an issue. I'd have to check with my engineering team and get back with you on that question, because I haven't seen an application where we have done that. These isolation valves are just knife gate valves. So you can see they're super easy to just spin back and forth and isolate it. If you want to get to the stone trap clean out, you could take this off, isolate it basically, isolate it down, and then isolate whichever side you need or both sides. There's on the back side, there's a little ball valve back here. You would drain the water, dewater it, and then there's 4 bolts right there. So it's super easy if you need to get to that stone trap clean out for the valves. But as far as actuated valves, I could ask our engineering team to get back to you with that question.
Without individual check valves, how does the shredding pump not have flow going backwards from on-line pump? Pressures remain high enough in the shredding pump.
So the shredding pump, I think what I heard her say is she's asking about the backflow. There's actually a flapper valve right here in between this where the discharge is. So there's a flapper valve, and then you wouldn't get any backflow from that. It's going to do that shredding action. The other pump's going to be on, but that flapper valve is going to be faced one way, whichever one's the lead pump. So it's kind of the built-in check valve where you don't get any backflow from that shredding action.
What are the typical operating hydraulic efficiencies?
So the hydraulic efficiencies, I mean, I'd have to get you some of our curves to see your specific application, but the vortex impellers in general are not going to be as efficient as your enclosed impellers or your typical different vortex impellers. Vortex impellers are designed so they're passing everything. So it will be using more electricity consumption, but you're not going to have any downtime essentially with this thing. So that's really where your return on investment is. These things are operated with VFDs, so they're going to operate and they're going to try to use as less energy as they possibly can to get your flow moving through. And then of course they're going to be sitting there idle and when it's not going to hit that high level set point. So as far as the energy consumption, I guess I could ask Jay that question. What if you're still on, Jay, and you could help answer that question? Have you seen any energy differences in this since we've installed it? Are you been able to
we have noticed we've noticed a lower electrical bill only because our other pumps were very inefficient. So I can't tell exactly what the new ones are, but I know they are a lot better than our older ones.
Yeah, that's a good question. And I always like to ask user experience for that because I mean, I just know what it says off the curve, but when someone can look at their energy consumption at a site after installing these things, I think that's the best feedback. Any other questions, Amanda? I know we got about 10 more minutes or so.
Can the system be reconfigured such that it adapts to an existing well with multiple inlet pipes?
Yeah, I think that's actually the system that Jay has. You can actually adapt this thing. What we would do here is we would have this thing. If you want to sit it down in the bottom of the wet well, you can sit this thing in the bottom of the wet well. You don't have to pack your confined space entry up. You can actually sit this down in the wet well. You can configure this so it's going up, and then so instead of horizontally, it's going to be flipped vertically, and then you can pipe in multiple inlets into the same inlet is what we've seen contractors and engineers like to do, and pipe it right down into the system. So I think there is 2 inlets at Jay's system. Is that correct, Joe?
Yeah, I have a 12-inch and an 8-inch inlet.
Yeah, 12-inch. Yeah. So yeah, it is possible. Let's see.
What happens in a system with multiple gravity pipes coming in a wet well?
Multiple gravity pipes. That would be like the same situation. We could just tie it right in, like we just said, and pipe it right down into OverWatch. Is what we would do.
It looks like there isn't much submergence for these pumps. Is air entrapment an issue for these pumps?
So air entrainment, I mean, the way that it's designed with this impeller, I'll try to get over here in front of my camera. It's going to take all that air and basically suck it right back out to the system. So I mean, it's going to go into that low cavitation mode essentially, and It's going to wait till it builds up pressure, and it's not going to be sucking up pressure. You can kind of see right here, we're operating at like half a pipe, and this thing doesn't ever really get airlocked at all. So it does handle that air entrainment, which is a little bit different than cavitation, but it does handle that well.
Can you talk about cycle time for these pumps? With no wet well, there's not much sewage volume to buffer cycling.
So the great thing about this is they are TEFC motors, so these things can cycle on and off a lot more frequently than they can a traditional submersible pump. These things can go a lot more frequently on and off, but you can set different level set points, so it's not going to be cycling on and off as much. You can see, I mean, we've had, I would say on a last spec sheet I saw for some regular submersible pumps, they had 60 starts per hour with their motor. And then we have TEFC motors, so we could do that, if not more. And if someone, there's probably not going to be an instance where this is ever going to go 60 starts per hour on these things. But the fact that it is not just going to that across the line, you know, full speed at 60 hertz, it's going to slowly ramp up every time it turns on with those VFDs. That's going to actually protect the motor as well. So there is motor protection on these devices.
Has anyone asked for redundant suction cover pressure sensors? What happens when they drift or fail?
So yeah, that's a great question. The level sensor down here, hooked back up to the control panel, we've seen engineers who like to kind of spec two of these things. So if something happens, the other one will kick on for redundancy. We have not had to replace any of these due to normal operations out in the field. But if, say you do have one, or even you have two, and something catastrophic happens, they both go out, it runs in a preset frequency mode. So it's going to be running and keeping your sewage wastewater going through the system. You're going to call out immediately when that happens to your host network. Someone can get out here, go do maintenance on it, and it takes about 4 minutes to isolate this thing and screw it back on. The good thing about the level transducer, it sits below the actual liquid, and there's a covering on it, a stainless steel covering on it. So it's a flush membrane, sits below it, and all the gravel, dirt is gonna be basically not touch it, so it doesn't damage it. So it is it's a robust IP67 level transducer that's stainless steel. So it's made to last. We haven't had to replace any. Good thing about our facility is we do have these on the shelves too. So it's just a regular level transducer too, but it runs in that preset frequency, and you're still not going to have any issues where it's going to be continually getting that sewage through your system.
What is the smallest pump system with the smallest connection?
I want to say I would have to go back to our reference list to get a very accurate number for you, but I know we have some of those simplex units, which is technically still the OverWatch 2, and I think there's one right in Jay's town actually. Jay, is that correct? There's one in your town. Is that a 1 horsepower or a 2 horsepower?
We have a 1 horsepower at a residence that's just outside the village.
Yeah. So a 1 horsepower, I mean, they can get very small. I think for our duplex, the smallest we have is a 2 horsepower or 3 horsepower, but they can get pretty small. So I think what you're kind of asking about is is basically the scouring velocity on the discharge. So what's going to happen with this is we want to meet that 2.5 feet per second or 3 feet per second. So we're going to look at whatever the system curve is, and we're going to say, okay, this is the actual frequency, minimum frequency we need to have to meet that scouring velocity. So if it is 38 hertz to meet that scouring velocity, not have settlement in your discharge, we're going to make sure it never runs below that 38 hertz. And what will happen too is if it gets scouring velocity in the discharge, you'll kind of see it on the inlet. You know, it's going to build up pressure to overcome that head. You're basically going to have to run your VFDs and your motor harder because you're going to have settlement in the discharge. The pump's going to have to run harder, and when it's running harder, it's going to move it right through the system. So it's going to meet that scouring velocity. But we can change it all in the control panel so it meets that scouring velocity on that discharge side.
What percentage of solids can the system handle?
I would have to go back to our spec sheet on that, the percentage of solids of it can handle, because I don't know that off the top of my head. But this thing will handle, I mean, 3-inch solids. It will handle, I don't know what percentage it will handle of solids, but typical wastewater, any wastewater application, this thing is going to handle it. So I can go ahead and get those numbers for you after this call.
Can you show the diverter on the unit that separates the two pumps?
The what? The diverter on the 2 units that separates the 2 pumps. So yeah, if you want to bring this over here, the camera, we can kind of get a closer look at this thing in operation. Let me point some things out for you. So this would be the main isolation valve. I think when you're saying diverter that separates the pump, maybe you're referring to the check valve in here that's going to swing both ways. We unfortunately can't see that in the middle of it, but it's going to have your 2 branch ways, one on each side. This is the knife gates if you need to isolate each side. The motors are here with that seal leakage detection right here. You can actually upsize the motors on certain sizes. So if something happens where you get extra capacity in the future, you can actually just upsize a motor if it will fit and on the same frame, and then get more capacity through your system. And this would be where that common discharge is. We typically see separate discharges, but on certain applications, but this one we have for compact reasons. And then there's a little flapper valve, which I can't point out since it's in operation, but that diverter, I'm assuming you mean that little flapper baffle in between those that's telling whichever pump's lead, it will swing one way or the other.
Is the control panel optional?
So we sell this as a complete unit. We will sell this with the control panel that you see today, but if you want to do any certain customizable things with the control panel, we can do it. As far as like, we still want the pump to like go into reverse when it has that, when it notices that, when it notices it has that torque deviation. And we can, but if you want to do anything regarding the control panel, a different type of enclosures, you want to actually never make it run into that mode where it does a PID regulating mode like you see today. You just want it to hit, it's never gonna see enough flow to go in the regulating mode. You can actually turn that off so it can just go in that linear on-off mode. Hits that high level point, goes down to a low level section. So there's a lot of customizable things in there that you can do if you reach out to us with your application. If there's anything special you want done, you can do that. And any special OmniSite or different types of SCADA systems, we can do that as well. Is there any other questions, Amanda? Well, I appreciate everyone for hopping on here. Again, we really appreciate it. We do have a live trailer of this thing. If you want to go see a live installation of this thing, or if you want to learn more about it, talk to our experts, go talk to our distributors, reach out to myself. I will send along a thank you for attending this after this, and you guys can get our contact information and we can talk about certain applications where you see this is fit. So I appreciate it. Thank you, everybody, and thank you for joining.